Now we have learned from our previous lesson that mixtures are joined or mixed together by physical means. So it can also be separated by physical means. And we will talk about the different methods or techniques in separating mixtures one by one, as well as provide you with examples of separating mixtures. So this will be our goal or target. At the end of the video, you should be able to identify the different techniques in separating mixtures, describe each of the techniques in separating mixtures, and name the benefits of the different separating techniques in our daily lives. So when we say technique, what comes into your mind? Or what does the word technique means? So technique is the same as a method or a process. It is also similar with the word manner or step, and it is synonymous with the words strategy and way. Going back to our lesson in mixtures, we already know that there are many different mixtures around us, some of which we use every day. And there are some mixtures that are useful while others are harmful or dangerous. Like I said a while ago, mixtures can be separated using physical methods. So it separates the parts of the mixture without changing their properties or identities. So you will still get the same material as the ones you have mixed together. Now, there are different properties of matter that are useful in separating mixtures. So sometimes we can separate mixtures based on their density or the ability to be attracted to a magnet or the boiling point or melting point of the materials in the mixture. So these are the common separation methods or techniques that we will discuss for today. So we have picking, filtration, sieving or sifting, decantation, use of magnet, winnowing, evaporation, distillation, and chromatography. So let's begin with the first method, which is physical manipulation. Wow, that's a long word, but actually it's just the same with the word picking. So when we pick, we use our hands. So it's a process of separating parts of a mixture by hand. So when can we use physical manipulation or picking? So we can use physical manipulation or picking when we have solid particles that are big enough to be picked in a mixture. So it's useful for heterogeneous mixtures of big solids. But if the solid materials in the mixtures are very fine or very tiny, so it's impossible to use this type of method. So I have here an example. Now, if you will try to get rid of the stones, no, that is mixed with the rice. So you pick the stones one by one to separate them from the rice grain. Okay, another good example is using your hand to separate the different parts or ingredients of your breakfast cereals. So if you have breakfast cereals that you bought a different stuff in it or different ingredients in it or materials in it, so you can separate these materials by picking. Example is using a fork to separate tomatoes, lettuce, cucumber, and onions in your vegetable salad. Okay, so it's not only limited to the use of your bare hands, but you can also use tools like fork or spoon or what else? Forceps, no, or tongue in picking out the. Okay, have here a very simple experiment that you can do at home. So the materials are readily available and you can buy them in your sari-sari store nearby or in the supermarket. So these are the things you're going to need. So we have peanuts. So naa na siya baligya nga happy peanuts. You can use that. Then we have corn kernels. Okay, kanang boy bawang. And then you have candy-coated chocolates or nips or M&Ms. So you will also need a big plate, three small containers or three small saucers or plate, then a timer. If you don't have a timer, you can use your watch or the timer in your cell phone. So this is what you're going to do. You're going to mix the nuts, the peanuts, the corn kernels, and chocolate candy in a plate, and you have to mix them well. Then after that, you're going to prepare the three small containers or saucers where you will put each of the individual material in your mixture. Then you're going to separate the materials in the mixtures using your hand. So by picking. And to add a little bit of a challenge, record the time it takes for you to finish separating each of the materials in the mixtures. Okay, now let's have another method or technique. So we have here filtration. So from the word filter. So filtration is used to separate heterogeneous mixtures composed of insoluble solids and liquids. So when we say insoluble, so this is the material that does not dissolve in water. Okay, so for example, you have sand and water. So our insoluble solid is the sand because sand cannot be dissolved in water. So in filtration, you're going to need a porous barrier or material to separate the solid from the liquid. What do we mean by porous? So I think this is a new word for you. But when we say porous, it has something to do with a material or any type of material that has very, very tiny spaces or holes in it. So the purpose of using a porous material is to trap the solid particle and allow the liquid to pass through the material. So in that way you will be able to separate the insoluble solid from the liquid. So basically that's the purpose or the use of the filter paper or cloth. So you have here an example. Okay, when we separate sand and water. So again, you're gonna need a porous material. So you can use a piece of cloth or handkerchief, or if you have a filter paper or coffee filter, then you can also utilize that. So basically, you're just gonna use also a funnel. But if you don't have a funnel, just simply place the filter paper or cloth on the mouth of the glass or your container, and then um, what do you call this? Tie it with a rubber band so that it will not move as you pour the liquid or the mixture into it. Okay, so upon pouring the mixture of water and sand into the funnel or into the filter paper, you'll notice that the liquid was able to pass through the filter paper while the sand is left in the filter paper or cloth. It wasn't able to pass through or penetrate into the material. Okay, so the end result will be your filtrate and your residue. When we say the residue, it is the material trapped in the filter paper cloth. So in this case, the sand will be our residue. And then we have our filtrate or the material that was able to pass through the filter paper or cloth. In this example, the water is our filtrate. I would like to give emphasis on the following words: residue and filtrate. So when we say residue, it is the insoluble solid left in the filter paper or cloth, while the filtrate is a substance or material that passes through the filter paper or cloth. So in our example, the sand is a residue and the filtrate is the water. So these are the uses of filtration in our daily lives. So this is the idea behind vacuum cleaners. So what vacuum cleaners do is it will suck up all the dirt and dust from your floor. And if you will try to open the vacuum cleaner, it has a filter on it that traps these dust particles. No? Okay, and also with the coffee maker, not to trap the what you call this, the granules of the coffee. No, but then it allows the water to pass through it. So it is also useful in water treatment. Okay, especially in dams, no, because when you try to make the water cleaner, you need to use filtration to separate the solid particles, the solid debris, or the sand, or whatever there is in the water from the water itself. Okay, so it's very important. And okay, this is very timely. In the time of pandemic, every time we go out, we have to wear our face mask. So what's the purpose of the face mask? So the face mask also is a filter system. So what it does, is it protects us from inhaling or breathing in, okay, the virus or the bacteria and other things, no, around us, like the dust also. Okay, so it protects us from the virus. Okay, here's another experiment. So this is just a very easy experiment you can do at home. So all you need is to prepare a mixture of water and sand and put it in a container or a glass. Then you'll have to prepare another container, but this time it's empty. And you have to secure filter paper or cloth with a rubber band on the mouth of the glass. But if you have a funnel, you can also use a funnel and then put the filter paper cloth in the mouth of the funnel or in the funnel itself. Okay, then slowly pour the mixture into the glass or container with a cloth or filter paper and observe what happens. So tell me what happens to the water and the sand and record your observation in your notebook or in a piece of paper. Okay, now let's go to sieving or sifting. Sieving or sifting is used to separate a dry and solid mixture, which contains substances of different sizes. So different sizes, there are fine particles and there are big particles in the mixture. So what it does is it uses a sieve or a sifter. So we all know what a sifter is, right? Because it is used in the kitchen. Okay, so it allows the fine particles or the fine material to pass through the holes while leaving behind the bigger materials. Okay, so that's the process of sieving or sifting. People know when you are baking and you try to, okay, sift the flour into the cookies or the pastry that you are baking. Also in construction sites, no, it's also very useful when they try to separate gravel from sand. So they use a big net, okay, to separate the gravel from the sand. Okay. So again, you use a strainer or a sieve or a screen so that only the fine particles can pass through it and prevents the larger ones from passing through. Okay. So that's the example of sieving and sifting. So separating sand from pebbles, you use a sifter or a sieve or a net, because it has holes in it as well. Now, another experiment you can try at home. So again, you will need materials that you have at home or you can easily buy. So you need a cup of rice, a cup of flour, and you need also plates to put the mixtures in it and one to hold the mixture that you're going, or the material that you're going to sift later. And of course, you need a sieve or a sifter. So what you're going to do is to mix the rice and flour in a container or plate. Okay, and then prepare a sieve and another plate. Then slowly pour the mixture into the sieve and observe what happens to the flour and rice. Record your observation in your notebook or in a piece of paper. All right, now let's go to the fourth method or technique, which is decantation. So decantation is used to separate immiscible solids, immiscible liquids or suspensions. When we say immiscible liquids, I hope you still remember immiscible liquids or liquids that do not mix well together or do not mix at all. Example are water and oil. So if you mix the two together, they will separate or they will not mix well together. It is a process of transferring liquid from one container to another without disturbing the settled particles. So you pour the liquid into another container, okay, and the settled particles or the sand or the floating particle, which is what or which is oil, will remain in the container also. Okay, so in this process, the mixture is left undisturbed. When the components are separated, the less dense substance can be removed by scooping using a spoon, or it can be removed by slowly pouring out the less dense substance. So I mentioned a while ago, so you can separate mixtures through their density. So decantation uses the density of the mixtures. No? So in this way, the less dense material will be removed from the mixture by pouring or by scooping. So pouring, scooping, so that's decantation. So this is an example here. So when you try to separate water and oil, so okay, since oil is less dense than water, it will float right on top of or it will float on top of the water. And you will also be able to separate it easily using a rod or a piece of stick or even just a spoon or fork. No? Okay, and then you put it in another container and slowly pour the mixture. So you will notice that you can easily separate water and oil this way. So you can try that at home also if you have time. Okay, so when you are washing rice, no, before cooking it, and then you pour the water from the rice, so that's already decantation. So again, decantation involves the process of pouring or scooping. So if you pour wine into a glass, that is also decantation. So if you notice, the bartenders they will slowly pour the wine into the glass. Nganong hinayon raman na nila no or yabo, so that the particles or the residue in the glass no will not be poured out together with the wine. Okay, and then again we have here separating oil and water. Okay, so decanting is done to separate particulates from a liquid by allowing the solids to settle to the bottom of the mixture and pouring off the particles or the particle-free part of the liquid. Another method is to allow two immiscible liquids to separate and the lighter liquid is poured off. So decanting is not only limited with immiscible liquids, but you can also use it with an insoluble solid and liquid mixture. For example, water and sand. So this way, you allow the sand to settle at the bottom of the container before you slowly pour the mixture or the water into another glass or container without disturbing the sand. Okay, next we have the use of magnet. So this type of technique can only be used if you have a magnetic material mixed with a non-magnetic material. So if there's a mixture of magnetic material like steel or metal or iron in a non-magnetic material. Okay, so it can be used to separate magnetic materials that are attracted to magnets, and it is used in food processing and in salvaging scrap iron and steel. So in the junkyard, normally they will use a big magnet like this to transfer or move the metals, no, from the pile of garbage or trash, no. So this way, it is easier to do their work or to be able to separate the magnetic and non-magnetic materials. Next, we have winnowing. So I think this is something new for you, okay? But it's just a simple process actually. So winnowing is a way or technique in separating mixtures by allowing the particles to fall from a height. So the lighter components get separated from the heavier ones because of the wind. Okay, this method is used to separate lighter husks from heavier grains like rice or wheat. So it is commonly used by, so it's used to separate chaffs from the grains by means of blowing or the current of air or wind. So farmers, like I said, use this technique to separate rice hulls from the rice grain. So the word winnow means to scatter by blowing. Okay, next we have evaporation. So I think you're very familiar with evaporation. So this technique is used to separate a dissolved solid from a solid liquid mixture, or in short, a solution. So the process typically involves heating the mixture until no more liquid remains. So it involves the use of fire. Okay, so the uses of evaporation is to obtain salt from seawater. So that's how salt is obtained. No, that's how we get salt from the seawater through evaporation. Okay, next we have distillation. So distillation in a way is also similar with evaporation because it involves heating, not the mixture. So it can be used mostly on homogeneous mixtures. So almost all homogeneous mixtures can be separated through distillation. So it is a separation technique that is based on the differences in the boiling point of the substances in the mixture. So for example, you have, okay, you mix alcohol and water and you wanted to obtain the water and separate it from the alcohol. So you can use distillation. So basically, the idea there is to heat the mixture, and then you also take note of the boiling point, no, of the materials in it. So in this case, alcohol, the boiling point of alcohol is 78, I think, degrees Celsius, while water is 100 degrees Celsius. So this way, the alcohol will be the first to evaporate. And when it does, the vapor will pass through a condenser where it is cooled down so that it will return to its liquid state. So from vapor into liquid again, and then it will be collected as distillate. Okay, so that is the idea behind the process of distillation. Okay, so distillation again is a process by which a mixture is separated by heating a solution and condensing using a cooling tube. So the liquid collected is the distillate. So how does simple distillation work? So you have here number one, in the distillation flask, water boils and enter the condenser. So because it will turn into water vapor, and then it passes through the condenser, this one. So what the condenser does is it cools down the water vapor so that it will turn into liquid again. Then after that, the pure water is collected into another container, and this is already called distilled water. Or in this case, if it's not water that you are trying to obtain, so it is called a distillate. Okay, perfumes, and in desalination plant, no, to separate salt from water. So, mo na trabaho sa mga desalination plant. And also to make distilled water. So we have the last one, which is chromatography. So chromatography is usually used by environmental groups or agencies in pharmaceutical companies, in the medical field, no, in the hospitals. Na. So what is chromatography then? So chromatography is the technique in separating components of a mixture based on the ability of each component or material to be drawn across the surface of another material. Okay, mixture is usually liquid and is usually drawn across a chromatography paper. So magamit siya chromatography paper in the process. So separation occurs because various components travel at different rates. So the component that is more attracted to the paper or has the strongest attraction to the paper travel the slowest. Okay. So it's used to identify also what material or substance is contained or is in a particular mixture. Okay, chromatography actually means color writing because it is used to separate materials or, for example, dyes from ink, no, dyes from ink to separate the different colored material found in an ink. Okay, so it's used for chemical analysis also. And then different substances or different components move at different speed, like I said, through a strip of wet paper, a gel, or a gas. So ang katong material that is strongly attracted to the chromatography paper will travel at the slowest rate. So what's the purpose or the use of paper chromatography? Again, to find the dyes used in ink. What color, no? Okay. And to detect alcohol level in the bloodstream. So it's used in hospitals, in laboratories, and even in forensics, no? So like I said, it's used in pharmaceutical companies to determine the amount of the chemical found in a new product or in a medicine. Also used in hospital to detect blood or alcohol levels in the patient's bloodstream. So in law enforcement, in the police force, or in the forensics department, it is used to compare, to get and analyze sample, no evidence from a crime scene and to compare it with a sample from a suspect. Okay, this is also important in getting DNA results, okay, or DNA samples. And it's also useful in environmental agencies to determine the level of pollutants in the water supply and to identify what chemical, what particular harmful material is in the water source. And in manufacturing plant to purify a chemical needed to make a product. Okay, so aside from the 9 techniques that I've already discussed, there are also other methods or ways in separating mixtures like floating. So from the word float, allowing a substance to float before scooping them out or before you pick them. Then we have sedimentation. Basically, it allows a solid particle like sand to settle at the bottom. That's the meaning of sedimentation. Then after that, you pour the liquid. Okay, next we have centrifuging. So it allows the mixture to move at a very or to be shaken or mixed or stirred at a very fast pace so that the particles will separate from each other. And we have crystallization. Okay, so that's it. So I hope you have learned something for today. And I do hope you would remember the different techniques in separating mixtures. Now, I have prepared here a very short evaluation or just a checkup test to assess or to you have understood our discussion for today. So kindly get a piece of paper or notebook and try to answer the evaluation. So there are two parts in the evaluation. So for the first part, letter A, okay, how can you separate the components of the following mixture? So basically, you're just gonna write what technique you're going to use to separate the components of the given mixtures. Okay, so good luck answering them. So you can pause this video so you can have enough time to answer the items in the test. For letter B, okay, you're going to choose from the words below. So it's just the same in letter A. You're going to write the technique that you're going to use to separate the given mixtures. So you have here picking, filtration, sieving, and decantation. Again, if you need more time to answer, just simply pause the video. Okay, let's go back to the different separation techniques that we have learned for today. So we have picking, using our hands to separate big or large particles of solid materials in a mixture. Then we have filtration, where we use a filter paper or a cloth to separate insoluble solids from a liquid. Then we have sieving or sifting, basically using a porous material like fil- like sifter or a net or a sieve to separate fine particles from bigger particles of solid materials. And then we have decantation, which basically means pouring or scooping and using of magnet or magnetism. Then we have winnowing, which is commonly used by farmers to separate rice hulls from the rice grains. And we have evaporation involving heating the mixture so that one of the component will evaporate, leaving behind the other component or material. Then we have distillation, which is also in a way similar with evaporation because it involves heating. But in distillation, the water vapor is collected and it is made to condense and turn into liquid again. And the mixture will be then separated and you will be able to collect the water or the liquid with the fastest boiling point. Okay, then we have chromatography, which is useful in hospitals, in environmental agency, in law enforcement, and pharmaceutical companies. So if you need time to review or if you want to go over the different techniques, I suggest simply watch the video again and you can also Google or search in the internet for more examples. Okay, thank you again for watching and I hope you have learned something new for today. So I wish you all a good day and continue learning.